Hello everybody, welcome into another lesson. So today we are going to talk about rotation of axes with conic sections. So you're probably wondering what the heck I have drawn here. Well, the idea is you can get distorted off-center conic sections by taking the original XY axes and rotating them so many degrees, which we'll call theta, the standard angle theta. So what you get is an x prime, y prime coordinate system as opposed to just an xy coordinate system. Now, yesterday we talked about, in the lesson about identifying conic sections, about the standard form of an equation for a conic section. So we have ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And we learned the shortcuts for identifying what type of conic section we're dealing with, which will definitely be put into use today. But notice we have an xy term, which we haven't had previously. When you rotate the xy coordinate plane so many degrees, it does yield an xy term. The idea is we want to start by finding the angle that we've rotated the normal xy plane. In doing so will enable us to get rid of the xy term and give us an xy equivalent to the x prime y prime. So how do you find the angle? To find the angle, you'll take the cotangent of 2 theta, set it equal to a minus c over b. So you'll take the cotangent of 2 theta, set it equal to the coefficient of the x squared term minus the coefficient of the y squared term, divide it by the coefficient of your xy term. And for today's purposes, theta is going to be between 0 and 90 to make our lives a lot easier. Otherwise, it could really get messy very quickly. Now, when you do that, once you find that angle, once you solve for theta, x is going to equal x prime times cosine of theta minus y prime times sine of theta, and then y will equal x prime sine of theta plus y prime cosine of theta. What you will do is substitute those into your original equation. In doing so, we'll cancel out the xy term and leave you with a new equation of a x prime squared plus c y prime squared plus d x prime plus ey prime plus f prime equals 0. This will give you an x prime y prime equivalent for your conic section to your xy plane. And we are going to graph these, but we're only going to want to get the vertices. We're not going to go crazy with these conic sections. We're just going to need the vertices so we can graph this, so we can graph these conic sections. So let's get started here. The black marker ink will be, for today's purposes, will be the x prime y prime plane. So that's what that's going to be. And then the blue lines, of course, on the normal magnet will be your normal xy plane. So let's go ahead and get started. Now, we're going to actually start with a real basic example here. Let's say we have something like xy plus 1 equals 0. So we have xy plus 1 equals 0. So we actually have a real basic rational function. But it's actually going to be a hyperbola because every rational function is technically a hyperbola. So we have identified this as a hyperbola, even though it's a real basic rational function. Now, first thing you always want to do, find your angle. So in this case, the cotangent of 2 theta is equal to, well, I don't have an x squared term, so a is 0. I also don't have a y squared term, so c is 0. So you'll have 0 minus 0 divided by your b term. That's going to be the xy term. The coefficient on that is 1. So cotangent of 2 theta is just going to equal 0. Now, where between 0 and 90 is the cotangent of 2 theta equal to 0? Or what gives you a cotangent of 0? What angle does? Well, that's going to end up being pi over 2. So 2 theta equals pi over 2. So that means theta has to equal pi over 4. So this is a pi over 4 angle in this case, or a 45-degree angle. So we've taken the original xy axis, we've rotated it 45 degrees. Now, the next thing we're going to want to do is find values for x and y to substitute in. So x, as we've already determined, is equal to x prime times the cosine of theta, so that'd be times the cosine of pi over 4 minus y prime times the sine of pi over 4. Okay, so that means then x is going to equal x prime. Now, what's the cosine of pi over 4? That's simply the square root of 2. So that'd be the square root of 2 over 2 times x prime minus y prime times what's the sine of pi over 4? That's also the square root of 2 over 2. So in short, you could say that x is equal to x prime times the square root of 2 minus y prime times the square root of 2 over 2. Now we're not done yet. We also need to solve for y. So y, as we determined, is always going to be x prime sine of theta. In this case, that'd be sine of pi over 4 plus y prime times the cosine of theta, which would be the cosine of pi over 4. Well, this is now about to turn into, let's see here, so y would equal x prime times the sine of pi over 4, which is the square root of 2 over 2. So you would end up getting x prime times the square root of 2 over 2 plus, you'll have your y prime. Now the cosine of pi over 4 is also the square root of 2 over 2. So that means y, we can substitute for x prime times the square root of 2 plus y prime times the square root of 2 all over 2. So now we have equivalent values in the xy coordinate plane for our x and y's. All that's left to do now are take these and substitute them into the original equation. So allow me to erase a little bit. I'm going to do a little bit of erasing because I want to make some room, so please forgive me for that. So let me go ahead here and bring some of these up. So x is equal to You know what? I better leave it how it was. So that's going to be square root of 2 over 2 times x prime minus square root of 2 over 2 y prime. And then y is equal to the square root of 2 over 2 times x plus the x prime, I should say, plus the square root of 2 over 2 y prime. Alright, so I've rewritten those. Let me erase all this so I can make some room. Okay, so now all I gotta do is take these values for x and y, substitute them into my original equation. So if I take the square root of 2 over 2 times x prime minus the square root of 2 over 2 y prime times the square root of 2 over 2 x prime plus the square root of 2 over 2 y prime plus 1, set that equal to 0, something very interesting is going to happen. Notice you have two binomials that are basically going to become a difference of squares. So square root of 2 over 2 x prime times the same term in the next binomial, that would end up being 2 over 4, or simply 1/2 x prime. And then you'll end up having, if you take the square root of 2 over 2 x prime times the square root of 2 over 2 y prime, and then you subtract the same thing from the next binomial, those middle terms will cancel out. Next will just be to take negative square root of 2 over 2 y prime. Actually, that should be an x prime squared, I'm sorry. But square root of 2 over 2 y prime times square root of 2 over 2 y prime negated, that's going to end up being minus 1/2 y prime squared. And then really we should move that 1 over to the right hand side. That should equal -1. So for your final result, of course, we can see we're going to have a hyperbola. This will actually end up being a hyperbola, but the right hand side in a hyperbola needs to equal 1. So divide everything through by -1. You'll end up getting y prime squared over 2 minus x prime squared over 2 equals 1. So there's an equation for the hyperbola in standard form in the x prime y prime coordinate plane. Well, the center of this hyperbola in this case would be at the origin in the x prime y prime plane. For the x prime y prime plane, that's where it is. Now, where are the vertices? Well, the y-axis is the major axis, right? So my a squared is 2, so I need to take the square root of a. I'll get plus and minus the square root of 2, won't I? So a squared equals 2. That means a equals plus and minus the square root of 2. So my vertices in the x prime y prime plane are going to be plus and minus the square root of 2, 0. Actually 0 plus and minus the square root of 2, excuse me, because y is the major axis. So 0 plus and minus square root of 2. That's for the x prime y prime system. So let's go ahead and graph what that's going to look like. Here's still my center at 0, 0. Now square root of 2 is going to be about there on my x prime y prime, and then the negative equivalent's right about there. I'm not even going to worry about asymptotes or anything. We're just going to draw the hyperbola. So look at this. There is going to be your distorted hyperbola. See how tilted that is on the x prime y prime axis? I think it's kind of cool how you can rotate these and get something completely different than what we're used to. Now, if it helps you, it's also good, and it's often going to be asked, what is the xy equivalent? Well, all you have to do to find the xy equivalent, let's find the center for that. The center, all you have to do is take your x and y values, plug those into your values for x and y. So x prime is 0, y prime is 0, the center is also at 0, 0. When you plug both of those values into your x and y values, you'll still get a center at 0, 0, but your vertices are going to change. So if I take the x coordinate of the vertices, take the x and y to get my x value, if I take 0 times my x prime, I get 0. Then if I take, let's see, so y prime, I would also have, let's see, if I just take square root of 2, because you'll have one positive, one negative, it doesn't matter which one I put in. Let's put in positive square root of 2. I'll end up getting, that would be negative 2 over 2, which would be negative 1. If I put it in here, I'd have positive 1. So my vertices are the equivalent to 0, 1 in the x prime, in the xy plane. So that's how you graph these distorted graphs on the x prime, y prime plane, where this is with the black marker. So what we did is we, of course, found our angle, and then we found our substitutions for x and y using x prime, y prime. We plugged those into the original equation, and then we got the equation of a hyperbola with a center and vertices in the x prime, y prime plane, and then we were able to find the xy plane equivalents. So that's just one example. Now let's do an example with a circle. I'm going to try not to destroy this whole entire x prime, y prime plane. This is just a bit of a mess today, so forgive me, but alright, let's erase that. Let's deal with the circle. So we have x squared minus 4xy plus y squared plus 1 equals 0. Well, it sure looks like a circle, and it actually is in theory. It is a circle, because your A equals your C, and they both happen to equal 1, so A equals C, which equals 1. This is actually a distorted circle. Now, of course, what we need to do is we need to find the angle that the xy axis is rotated, giving us the x prime, y prime plane. So take your cotangent of 2 theta, set that equal to your A coefficient, which is 1, minus your C coefficient, which is the y squared, which is also 1, divided by your B coefficient, which is negative 4. Well, that's just going to be 0, right? Well, what angle gives us a cotangent that's 0? That's going to be pi over 2, so 2 theta equals pi over 2, which means theta once again has to equal pi over 4. So this angle here is pi over 4, or a 45-degree angle that we've rotated the xy axis. Now, what we need to do is find, once again, values for x and y that will get us into the x prime, y prime plane. So, x is going to equal, of course, x prime times the cosine of theta. Well, that's the cosine of pi over 4 minus y prime times the sine of pi over 4, which of course that would simplify that into x equaling square root of 2 over 2x prime, because cosine of pi over 4 is the square root of 2 over 2, minus, now what's the sine of pi over 4? That's also the square root of 2 over 2 times y prime. So there's the substitution for x. Now the y, on the other hand, is going to end up being, in this case, of course, it's always x prime times the sine of theta, which is the sine of pi over 4, plus y prime times the cosine of theta, which that theta is pi over 4. Okay, so sine of pi over 4 is square root of 2 over 2, so that'd be the square root of 2 over 2 times x prime, plus the cosine of pi over 4, that's the square root of 2 over 2, then times y prime. So now we found our x and y values that we can substitute in. Okay, so let's go ahead here and let me condense some of this. I know we found the angle now. If you need to see how we found the angle, please feel free to rewind this. There's no harm in doing that. So x is going to equal square root of 2 over 2x prime minus square root of 2 over 2y prime. And then y is going to equal square root of 2 over 2x prime plus square root of 2 over 2y prime. Because what I have to do now is I've got to simplify this equation. So I'm going to take that value of x, substitute that in for x squared. So we'll take the square root of 2 over 2 x prime minus the square root of 2 over 2 y prime, square that, minus 4 times my x was the square root of 2 over 2x prime minus square root of 2 over 2y prime times the quantity, which is y, square root of 2 over 2x prime plus the square root of 2 over 2y prime plus the y squared. So now we need to substitute this y value in for y squared, so that would end up being square root of 2 over 2x prime plus square root of 2 over 2y prime squared plus a 1, all that equals 0. So I took my respective values of x and y, I just simply substituted them into the original equation. So let's work on simplifying this. So if we take the square root of 2 over 2x prime minus the square root of 2 over 2y prime, and we square that whole quantity, so square the first term, you get 2 over 4, which would be 1/2 of x prime squared. Now, we got to take 2 times these two terms multiplied together. So, square root of 2 over 2 times the same number, that would again be 2 over 4. Multiply that, you get 4 over 4, which is 1. So this would end up being minus x prime y prime. And then if you square the final term, you'd have 2 over 4, so that'd be plus 1/2 of y prime squared minus, let's do the whole quantity here. So actually minus 4 times the quantity. So let's multiply these two together. We should just get a difference of 2 squares. So square root of 2 over 2 times x prime times the same thing. That would be 1/2 times the quantity of x prime squared. The middle term should cancel out when we FOIL. So if we take negative square root of 2 over 2 y prime times square root of 2 over 2 y prime, we should get minus 1/2 times y prime squared. All that, let me denote what I'm doing here. Then we still have plus the y squared, so that'd be this value for y. So if we square the first term, square root of 2 over 2 squared gives you 2 over 4, which would be plus 1/2 x prime squared. Then you take the two terms, multiply them, then multiply them by 2. So square root of 2 over 2 times square root of 2 over 2 is 2 over 4 times 2 is 4 over 4. That's just plus x prime y prime. And then you square the second term, you get 2 over 4, which is plus 1/2 of y prime squared plus 1 equals 0. I know I have a bit of a mess. Please bear with me, because I'm going to take what I just did, I'm going to simplify all this by collecting like terms and write the brand new equation up here. So if you need any of this, please feel free to rewind the video. Okay, so we're going to collect like terms. So you have here, actually, let me erase the initial part first, because I need to expand the 4. This is really going to be difficult, but not difficult, but a lot. So let's write what we have here. So we have 1/2 x prime squared minus x prime y prime plus 1/2 y prime squared minus, okay, so we have minus 4 times 1/2 x prime squared. That would be minus 2 times x prime squared minus 4 times negative 1/2 y prime squared. That'd be plus 2 times y prime quantity squared. And then we have here, we have plus 1/2 x prime quantity, x prime squared plus x prime y prime plus we have 1/2 y prime squared plus 1 equals 0. So I know this just got really hideous really fast, but we're actually about done simplifying, because all we have to do now is collect like terms. So if we collect like terms, you'll end up getting 1/2 x prime squared. Then you have another plus 1/2 x prime squared. Well, that's actually going to be x prime squared minus 2x prime squared. That would give you negative x prime squared. And then you have, notice your x prime y prime negative, then plus that same term. Those are going to cancel out. So your x prime y primes have canceled out. Now let's just deal with the y prime squared. So you have 2y prime squared plus 1/2 y prime squared plus 1/2 y prime squared. That's actually going to be 3y prime squared. Plus 1 would equal 0. Well, that's just going to equal -1. So in actuality, we weren't really dealing with the circle. They deceived us. So when you're dealing with equations, of course I gotta drop something. When you're dealing with equations where you have an actual xy term and you have a rotated axis, you can't make the final judgment until you got your x prime y prime equation. So that's when you would make the judgment. This is actually going to be another hyperbola. But we want the right hand side to equal +1, so divide everything through by -1. And what you'll end up getting in your simplified form is going to be 3 times y prime quantity squared. No, that's not right. Divide everything by -1, you'll get x prime squared minus 3y prime squared equals 1. If I could quit dropping stuff today, that would be amazing. Okay. Well, the only thing is now, in order to write this in standard form, we need to have a coefficient of 1 on that y prime squared. Well, we have 3 times that. That's the same as dividing by 1/3. So this equation in standard form would be x prime squared minus y prime squared divided by 1/3 is equal to 1. Now we have this hyperbola in standard form. So let's go on ahead here and find the center of this hyperbola in the x prime y prime plane. The center, of course, is going to be at 0, 0. Now we need to find the vertices. Well, a squared equals 1, so a would equal plus and minus 1. And it's plain to see the x prime axis is the major axis. So we're going to affect the x coordinates of the center. So the vertices would be at plus and minus 1, 0. So now we actually have enough to graph this hyperbola. And there is your distorted, twisted hyperbola with a 45-degree rotation. Now the only thing left to do is find the xy equivalent. So if I want to find the xy plane equivalent of the center, for my x, I'll put in both my x prime and y prime values. Well, 0 times anything is 0. So the x coordinate of the center is 0. Now the y coordinate, we'll just put in both x and y values for our x prime and y prime into this equation. 0 times anything is 0. So the center still stays 0, 0. What's going to change are the vertices. So the vertices then, well, that's the thing. You will have two vertices, but notice the y-coordinate of your center, the y-coordinate of your vertices is a constant 0, so in the y prime, so no matter what I get, I'm going to be left with a positive square root of 2 over 2 times x prime in both equations. So all that's left then is to put in my x, because we know y is going to be a constant 0. If I put in both plus and minus 1, I'll have plus and minus the square root of 2 over 2 for my x-coordinates of the vertices in the xy plane. So that's how I would find my xy coordinates in the xy plane. Alright, let's go ahead and do one more, because I know these can be kind of lengthy. I know these are just a little bit lengthy, and I'm sorry about that, but this is pretty important. Good news is, after this, from what I can see, from what I've studied before, this doesn't come up a whole heck of a lot, but I still got to teach it. It's still my job to teach it, so let's do one more. I'd like to find something besides a hyperbola. All right. We just did that one. Let's try this one. So we have 3x squared minus 2 times the square root of 3xy plus y squared plus 2x plus 2 times the square root of 3y is equal to 0. What a doozy this one's going to be, isn't it? What a doozy. So you have 3x squared minus 2 times the square root of 3xy plus y squared plus 2x plus 2 times the square root of 3y equals 0. Well, we need to, of course, first find the angle that this axis is rotated. So the cotangent of 2 theta equals a minus c in the numerator. So the a is the coefficient on the x squared, that's 3, minus our c, which is the coefficient on the y squared, well, that's just 1, all over b, that's the coefficient on the xy, which is negative 2 over the square root of 3. Which means the cotangent of 2 theta is going to equal 2 over negative 2 times the square root of 3, which would end up giving us negative 1 over the square root of 3, or yeah, it would be negative 1 over the square root of 3. So actually we're going to end up having a second degree, a second quadrant angle. This will be the only one where we have a second quadrant angle. So yeah, it just, you know what, let's change that to a plus for simplicity's sake. I'd rather keep this in the first quadrant. So you would just have positive 1 over the square root of 3. Okay, what angle gives you a cotangent? A cotangent of what angle, rather, would give you 1 over the square root of 3? Well, let's draw ourselves a 30, 60, 90 triangle. Right, so 30 degrees, 60 degrees, there's the 90. The angle across from 30 is always 1. Angle across from 60 is always the square root of 3. And then the 90, the hypotenuse, is always 2. Alright, well, the cotangent is adjacent over opposite. 1 over the square root of 3 is 60. In this case, then, that means 2 theta has to equal pi over 3, since that's a 60-degree angle. Well, take pi over 3, divide it by 2, you end up getting theta is equal to pi over 6. So the xy axis has been rotated pi over 6, or 30 degrees, to give us the new x prime y prime plane. Alright, so now we've obtained our angle, let's obtain our special equations for x and y. So x always equals x prime times the cosine of theta, which is going to be the cosine of pi over 6, minus the sine of theta, which would be the sine of pi over 6, which means x is going to equal what? Well, the cosine of pi over 6, the cosine of 30 is the square root of 3 over 2. So you'll have the square root of 3 over 2 times x prime minus, now what's the sine of pi over 6, or the sine of 30? It's 1/2, so this would be minus 1/2 y prime. Now we need to find the y. So y, of course, is going to always be x prime times the sine of theta, which would be the sine of pi over 6, plus the cosine of your theta, which would be the cosine, or y prime, I should say, cosine of theta, which would be pi over 6. So y would equal x prime times the sine of pi over 6. That'd just be 1/2 of x prime. And then you'll have, well, y prime times cosine of pi over 6. That'd be plus square root of 3 over 2 times y prime. So now we have our equations for x and y converted into x prime, y prime. Let's go ahead here and make some room. Again, feel free to rewind the video if you need to. I'm going to write my x and y substitutions up here. So x is going to equal square root of 3 over 2 x prime. Actually, why don't I write these over here, because I think we have a general idea what the equation was. I want to make more room. So x equals square root of 3 over 2 x prime minus 1/2 y prime. And then we have y equals 1/2 x prime plus square root of 3 over 2 y prime. Alright, there we go. Make some more room here, huh? Well, I can substitute those into my original equation, because if I take the 3x squared, so that's going to be 3 times this value of x which is squared, so that'd be square root of 3 over 2 x prime minus 1/2 y prime squared plus 2 times the square root of 3 times my x, which is the square root of 3 over 2 x prime minus 1/2 y prime times my y, which was 1/2 x prime plus square root of 3 over 2 y prime. What's next? Plus the y squared. Well, the y was 1/2 x prime plus square root of 3 over 2 y prime squared plus 2 times this value of x, so that'd be the square root of 3 over 2 x prime minus 1/2 y prime plus 2 times the square root of 3 times my y, which is 1/2 x prime plus square root of 3 over 2 y prime. All that is equal to 0. And holy moly, that got pretty bad pretty quickly. But the goal is, again, we will eliminate the xy term and we'll have a much simpler equation in the x prime y prime. So let's go ahead and do some multiplication here. Well, 3 times this value squared, so that's going to be 3 times square root of 3 over 2 x prime squared. That would end up being 3/4 times that x prime squared. Now I just got to take these two terms, multiply them together, then multiply them by 2. So square root of 3 over 2 x prime times negative 1/2 y prime. That gives me negative square root of 3 over 4. Then if I take that, multiply it by 2, that ends up giving me negative square root of 3 over 2 x prime y prime. And then let's see here. So I take, of course, that negative 1/2 y prime, and I square that, I'll get plus 1/4 y prime squared. And that's just my first term. Plus, if I take 2 times the square root of 3, I'm going to FOIL all these. 2 times the square root of 3 times these two FOILed, so square root of 3 over 2 x prime times 1/2 x prime, that'd be square root of 3 over 4 x prime squared. Now let's see, so square root of 3 over 2 x prime times square root of 3 over 2 y prime, that'd be 3 over 4 x prime y prime. And then negative 1/2 y prime times 1/2 x prime, that'd be minus 1/4 x prime y prime. And then negative 1/2 y prime times square root of 3 over 2 y prime, that'd be negative square root of 3 over 4 y prime squared. I know I'm running out of room here. I'll make this bigger here in a second. Now I just still got to deal with these three terms. So if I square this, so 1/2 x prime squared, that'll be plus 1/4 x prime squared Now multiply these two terms and multiply that by 2. I would get square root of 3 over 4 times 2. That'd be plus square root of 3 over 2 x prime y prime. Then I square the last term. I would end up getting plus 3/4 y prime squared. And then, let's see, I still have two more terms. So the 2x term would just be 2 times this. So that would end up being plus, if I distribute that 2, that would end up being square root of 3x prime minus y prime. And then I just distribute the 2 times the square root of 3 through. I'll end up getting plus the square root of 3x prime. And then 2 times the square root of 3 times square root of 3 over 2. That would end up being 6 over 2, which would be 3y prime. So that'd be plus 3y prime. All that equals 0. And yes, I'm going to simplify this up top here. I got to do some distribution here first. So let me distribute the 3 through my first term here. So 3 times 3/4, that's going to end up giving me 9/4 x prime squared. Alright, then minus 3 times the square root of 3 over 2 x prime y prime plus 3/4 y prime squared. Now I got to distribute this 2 times the square root of 3 through this whole thing. So 2 times the square root of 3 times the square root of 3 over 4. So you have 6 over 4. So that would end up being, you know, let's do plus 6 over 4. There's a reason for that because of the 9/4. So plus 6 over 4 x prime squared. Now 3/4 x prime y prime minus 1/4 x prime y prime. That's 2/4, which would be 1/2 of x prime y prime. Well, half of the square root of 2 times the square root of 3, that's just plus square root of 3. Or you could say 2 times the square root of 3 over 2 x prime y prime to make your life a little bit easier. And then 2 times the square root of 3 times the square root of 3 over 4, the negative of that, you get minus 6 over 4 times y prime squared. Then just add all these other terms. You'll have plus 1/4 x prime squared plus square root of 3 over 2 x prime y prime plus 3/4 y prime squared plus square root of 3 x prime minus y prime plus square root of 3 x prime plus 3y prime equals 0. Alright, now we should be able to do one more simplification by collecting like terms, and we should have the final equation. Let's figure out all of the x primes first. The x prime squareds. So you have 9/4 plus 6/4 is 15/4 plus 1/4 is 16/4. So you would have 4 times x prime squared. So we've simplified the x prime squareds. let's see if we can eliminate the x prime y prime term. So negative 3 times the square root of 3 over 2 plus 2 times the square root of 3 over 2. So that's negative square root of 3 over 2 plus square root of 3 over 2. That eliminates the x prime y prime variable. That's gone. Alright, next let's figure out the y prime squared. So you'll end up having 3/4 minus 6/4 is negative 3/4 plus 3/4 is 0. So actually then it looks like we don't even have a y prime squared. Well, that's awfully nice, isn't it? That's really nice. So the y prime squareds are gone. So now let's go right away for just the single x primes. And you just have square root of 3 plus square root of 3, so you'll end up having plus 2 times the square root of 3x prime. And then what about your y primes? So you have just a negative y prime plus 3y prime, so that'd be plus 2y prime is equal to 0. So what you're going to have actually here is a parabola. That worked out to be a parabola. So let's work on getting this into standard form. I'm going to erase everything up top. Again, feel free to rewind the video. So always what's true is your quadratic factor has to be on the left-hand side. Your linear term should go to the right-hand side. So to simplify this, you'll have 4 times x prime squared plus 2 times the square root of 3x prime is equal to negative 2y. So this will end up being, or negative 2y prime. This will end up being a parabola with y-axis symmetry that's tilted. Well, what's true then? We need to make the variable on the x prime squared, we need to make that the coefficient rather a 1. So we need to factor out a common 4. So you would end up then getting, alright, so that'd be 4 times your x prime squared. So we'll have 4 times the x prime squared. This would be plus the square root of 3 over 2 times x prime is equal to negative 2y prime. Okay, so now we just need to complete the square. So we would end up having 4 times, alright, so we have, let's just pretend that's x squared and the square root of 3 over 2x. So half of square root of 3 over 2 is the square root of 3 over 4. You square that, you'll get 3/16. So this would end up being the quantity of x prime squared plus the square root of 3 over 2x plus 3/16, or x prime I should say, equals negative 2y, but we got to complete the square on the other side, so 4 times 3/16, that would end up being plus 3/4. I'm going to come up here a bit now to simplify this further. So you'll end up having 4 times this quantity of x prime plus the square root of 3 over 4 squared is equal to Now, your y variable should always have a linear term. Well, first, let's just set what this is equal to. Negative 2y plus 3/4. Okay? Well, the coefficient outside of the parentheses for your quadratic term should always be 1. Always. So this is going to simplify then into, if we divide both sides by 4, you would end up getting x prime plus the square root of 3 over 4 quantity squared. Divide the right hand side by 4, you'd end up getting negative 1/2 y plus 3/16. Now the coefficient on inside where the linear term is going to be should also be 1. So we should factor out a negative 1/2. So you would have x prime plus square root of 3 over 4 squared is going to equal negative 1/2 of the quantity of y minus 3/8. Alright, so now we have this equation of the parabola in standard form, finally. So this ends up being, that's a y prime. Okay, so this ends up being the quantity of x prime plus the square root of 3 over 4 quantity squared equals negative 1/2 times the quantity of y prime minus 3/8. Well, that is going to be the standard form of the parabola in the x prime y prime plane. So let's get all the results for that. And all we really need in this case is the vertex. X prime, y prime. The vertex, of course, set your x prime plus square root of 3 over 4 equal to 0. You get negative square root of 3 over 4 for your x coordinate. Set your y coordinate equal to 0. Set your y prime minus 3/8 equal to 0. You get y prime equals 3/8. So the vertex in the x prime y prime plane, oh boy, let's take that, huh? Negative of the square root of 3, now divide that by 4. That puts your x coordinate at about negative 0.43, and then 3/8 is a little under half, so right about there. And this is going to have y-axis symmetry, so your parabola is going to look something like this. So there's your distorted parabola on the x prime y prime plane. Now let's find the xy equivalent. So to find the xy equivalent, let's take your x and y values and substitute these in for the x prime y prime to find your x coordinate. So x would equal, of course, square root of 3 over 2 times your x coordinate of negative square root of 3 over 4 minus 1/2 times your y coordinate of 3/8, which would end up giving you negative 3 over 8 minus 3 over 16. So that should be negative 6 over 16 minus 3 over 16. So my x coordinate should be negative 9/16. So the vertex for the xy plane, the x coordinate is going to end up being negative 9/16. Now let's see about what happens here with the y. If you need this, feel free to pause or rewind to see how I worked out the x for the xy plane. We now need to put all this in to get the y coordinate. So the y coordinate, I'll take all those values of x prime, y prime, substitute them in for y. So y is going to equal 1/2 of my x prime, which is negative square root of 3 over 4, plus the square root of 3 over 2 times my y prime, which was 3/8. So that's going to simplify into negative square root of 3 over 8 plus 3 times the square root of 3 over 16, which should end up giving me negative 2 times the square root of 3 over 16 plus 3 times the square root of 3 over 16, which should just be square root of 3 over 16. So the xy equivalent of this vertex would be at negative 9/16 square root of 3 over 16. So I know this was a long lesson, and good news is this really shouldn't come up again, at least not for many courses from now. But that's it for how to deal with conic sections with rotated axes. Next lesson will be much easier. We're just going to get into parametric equations and graphs of those equations. So I hope everyone has a great day. Take care.